Okay guys, today we're going to talk about acids and bases in more detail. In the last lesson we introduced what an acid and a base is. In this lesson we're going to take it a step farther and actually quantify an acid and a base based on the pH scale. I'm going to teach you how to calculate what the pH of a solution will be and how they do that. So let's get started. Please have your Chapter 11 guided notes out. You're also going to need a calculator. So if you're watching the video, you need a calculator and your Chapter 11 guided notes. Okay, so let's get started. The pH scale, which we introduced last time, goes from 0 to 14. It's a way of expressing the strength of acids and bases. Right at 7 is neutral. This would be water. So guys, if I'm at a pH of 6, is that a strong acid or a weak acid? This is very weak. Now, what if you're at a pH of 1 or 0? That's a very strong acid. Now let's go to the bases. What if it was a pH of 8? It's basic, but is it a strong base or a weak base? Weak. Always remember, if it's by 7, which is water, it's almost neutral. It's very weak. As you move further away from 7, though, it gets very strong. And so a pH of 13 or 14 is a very strong base. Okay, we also introduced this last time. The more H plus ions you put in a solution, the more acidic it becomes. And here's how they love to ask this question because it tricks students. If I put in more H plus ions, what's going to happen to the pH? Goes down. It's going to go down. So if you put in more of these guys, the pH actually goes down. So just remember that. Okay, and then also, we introduced this last time, hydroxide ions. If you put more hydroxide ions into a solution, it makes it more basic. So if you increase the concentration of hydroxide, what is that going to do to the pH? Is it going to make the pH go up or down? Up. It's going to make it go up. So that one does kind of make sense in how we think about it. But be careful with the acid. Remember, acids are lower than 7. So if you put in more H+, the pH is going to fall. It becomes stronger acid. Okay, so under 7 is an acid. Right at 7, that's neutral. And of course, over 7 is a base. So we're going to get into calculating the pH of a solution. In pure water at 25 degrees Celsius, this is what happens. Water can sometimes, one water molecule will take a hydrogen from the other water molecule and become H3O+, which as we learned last time is the same thing as H+. Well, if it takes a hydrogen from one of these other molecules, it leaves hydroxide. In pure water, the H plus and the OH minus are going to be in equal concentrations. So here's what this means. The H3O plus concentration of water is 1 times 10 to the minus 7th moles per liter. The OH minus concentration in pure water is 1 times 10 to the minus 7th moles per liter. What do you notice, guys?
They're the same.
They're the same because you form 1 H plus for every 1 OH minus in pure water. I want you to write this. I didn't include it in the notes and I should have. When you see brackets in chemistry, so I want you to write this in your notes somewhere in the margin. When you see brackets in chemistry, this is telling you that they are reporting a concentration. So please make that note. Brackets in chemistry mean concentration. We learned a couple of chapters ago how to calculate concentration. What do we do it in? It's given this symbol capital M. What does that mean? Molarity. How do we calculate molarity? Good. We take the moles of the solute and divide it by the liters of the solution. Moles divided by liters. So please make that note. So again, H3O plus in brackets tells us the molarity of the H plus ions in the solution. If you see OH in brackets, it's telling you the molarity of the hydroxide ion in the solution. So to calculate the pH of a solution, we need to measure the molarity of the H3O plus ion or the hydroxide ion. We need to measure it in terms of its molarity. Concentrations of H plus ions are often very small. These numbers are going to be very small. So you're going to see them expressed in scientific notation. Remember how to use scientific notation. You're going to see that a lot in this chapter. This is the most important thing of the lesson. The definition for pH is the negative logarithm of a hydrogen ion concentration of a solution. Let me say that again. You're supposed to write it. pH is the negative logarithm of the hydrogen ion concentration of the solution. How many of you guys in your math class have learned about logarithms? Okay. Hopefully you have by now, but if you haven't, you're going to be okay. Logarithms is how we determine the pH of a solution. We take the negative logarithm of the H plus concentration. So in your guided notes, you're supposed to write this formula. To calculate pH, here's how a chemist would do that. They would take the negative logarithm of the H plus concentration. Remember, these brackets are in molarity, so it better be in terms of molarity. Okay, just a little bit about logarithms. Like it says here, the logarithm of a number is the power to which 10 must be raised to equal that number. Let me see if I can make that make a little more sense to you. If I said the log of 10, what that is saying, guys, is the number to which 10 must be raised to equal that number. What is the log of 10? Well, it's 10 raised to what power? 10 raised to what power equals 10? What exponent would I need right there?
1.
A 1. Let's try that on your calculator. If you're watching the video, please have your calculator out and hit log of 10. The logarithm of 10 is equal to what? This is equal to 1. So the power to which we need to raise 10 by to equal that number, what's the answer there? Well, it's just 1. That's what logarithms mean. If you understand that and you've had that mathematics before, great. If not, all you need to do is have a calculator and be able to find the logarithm button. Let me see if I can help you with this. It says, using your calculator, find the pH of the following solutions. Now, this is not in your guided notes, but I would like you to try it. Okay, let's find the pH of this solution. 0.000001 molar solution of HCl. HCl is our acid, so there's our H plus concentration. So here's how we do it. pH is equal to the negative log of 0. How many zeros were there? 1, 2, 3, 4, 5, 6 zeros. Okay. Find your calculator. Let's turn it on and hit the negative button. Okay, so find the negative button, which is at the bottom of our calculators. Hit that, and then hit the logarithm button, which is right below the second function on the calculator that we use. So negative log, and then type in point. There's 6 zeros here. 1, 2, 3, 4, 5, 6 zeros, and then a 1. What do you guys get? Yeah, the pH of this one is equal to 7. I'm going to put a few more up here, and I want you to calculate the pH of these guys. So just hit your up arrow on our calculators and delete one of the zeros here. What do you get for the pH of this one?
6.
It's equal to 6. What's the pH of the next one?
5.
5. pH of the next one. 4, 3, 2, and 1. Now you might have noticed the trick, but let me show you. Yeah, so you might have noticed the trick, but here's what I hope you realized. The pH, guys, if the concentration of your acid ends in a 1, and it only works if this number is a 1, all you have to do is determine how many times you have to move the decimal so that it's right at 1. So this is 1, 2, 3, 4, 5, 6, and 7. So it's a pH of 7. So pH is a logarithmic scale based on powers of 10. How many times did we have to move the decimal here? 6. How many times do you have to move the decimal here? Just 1. So it's a pH of 1. Notice, as the concentration of hydrogen ion increases, this is way more concentrated than number 1, the pH does what? It goes down. Okay? So you simply count the number of times you move the decimal point, and that is the pH. But that trick only works if this is a 1. If it's not a power of 10, what if it ended in a 2? Would that work? No, you would need to use your calculator. So I've got a few practice problems for you to try. Please have your calculator out. Practice problem number 9. I want you to find the pH of this solution. It is a 0.001 molar solution of HCl. This is my H plus concentration. So pH is equal to the negative logarithm of the hydrogen ion concentration, which was right here, 0.001. Now, this one is ending in a 1, so can I use my trick?
Yeah.
Sure. What's the pH?
3.
Is equal to 3. And if you want to use your calculator to double check yourself, it should be a pH of 3. Guys, is that a strong or a weak acid?
Strong.
It's kind of medium, right? It's right in the middle. It's kind of almost where it becomes strong, but it's still kind of weak. Okay, pH of 3. That is correct. Let's go to practice problem number 10. Now be careful with this one. It's not ending in a 1. You're going to have to use your calculator. So please try it. Use that formula, calculating pH, and tell me what the pH is. If you're watching the video, please hit pause and see if you can get this one. Okay, guys, let's see how you did. I would do this. I would write down the equation for pH. And now let's just plug in what we know. We want to find the pH. We're going to take the negative logarithm of this hydrogen ion concentration, and it said it was at 0.09 molar. So if we grab our calculator, negative log of 0.09, you should get that the pH is equal to 1.0, if you round it to 2 decimal places, 1.05. Couple questions. Acidic or basic?
Acidic.
It's acidic. It's less than 7. Strong or weak acid?
Strong.
Yeah, that's a pretty strong acid. That's pretty close to 0, so I would say that would be a strong acid. Okay, hopefully you got that one right. I've got a couple more for you. So practice problem number 11. Find the pH of this solution. Again, it doesn't end in a 1. Please try it by using that equation for calculating pH. You need a calculator. So please try this one on your own. Once you get an answer, hit play and see if you got it right. Okay, so hopefully at this point you have an answer for this practice problem number 11. So here's how I would approach this problem. It says find the pH of a 1.34 times 10 to the minus 4th molar solution of HCl. This is our acid. That's our H plus. So let's write down the formula for pH. It's equal to the negative logarithm of the hydrogen ion concentration. So now let's simply plug into this formula. So pH is equal to the negative logarithm. Now my hydrogen ion concentration, they gave it to me right here, 1.34 times 10 to the minus 4. So if you put that in your calculator, you will be able to find its pH. So negative log of 1.34 times 10 to the minus 4. And so I'm getting that the pH was equal to 3.87. 3.87. Now, is that acidic or basic? Hopefully you're thinking to yourself that that is an acidic solution. Would it be a strong or a weak acid? And I would say it's kind of right in the middle where it changes from weak to strong. But anyway, 3.87 is your answer. All right, I've got another one here. Practice problem number 12. This will be the last practice problem on this lesson. And it's a little more complicated, so let me help you get started. It says, find the pH of a 735 liters of solution containing 0.34 moles of HNO3, which is nitric acid. A little more complicated because it didn't come out and give us the concentration of this acidic solution, but it did give us a way to find it. Okay, I want you to remember, the brackets mean molarity. And molarity we find by taking moles divided by liters. So you first need to do that to figure out the concentration. Then you can plug it into your pH equation and calculate its pH. So I'm going to leave you at that point. If you're watching the video, please try it on your own. See if you can't come up with the answer. I want you to calculate its pH. Once you have the pH found, then hit play and see if you got it right. Okay, so let's see how you did with this one. Like I said, it didn't give us molarity right off the bat, but it did give us moles. So I'm going to put in for moles was the 0.34. And molarity is calculated by taking moles divided by liters. We had 735 liters. Okay, so I'm going to grab my calculator and hit 0.34 divided by 735. And I get this number, 0.000462585. Okay, very, very small number. So we want to express this in scientific notation. I hope that you can remember how to do that. But we got to slide this decimal how many times until there's one number to its left? So there's 1, 2, 3, 4. And so this becomes 4.6 times 10 to the 1, 2, 3, 4. But we moved it to the right, so this is a very small number, so it's going to have a negative exponent there. So the answer is 4.6 times 10 to the minus 4. Now this is my H plus concentration. My H plus concentration is equal to that. So now when we calculate the pH, it's equal to the negative logarithm of the H plus concentration. So let's take that and plug in the negative log of 4.6 times 10 to the minus 4. You grab a calculator, the negative log of 4.6 times 10 to the minus 4. And I'm getting that the pH is equal to 3.34. And would that be acidic or basic? And hopefully you're thinking to yourself, that's an acidic solution of 3.34. Is it below 7? So it's definitely acidic. Okay, let's see if we got it right. And we did. All right, that's it for this lesson. Hopefully that makes sense on how you calculate the pH of a solution. Remember this formula. It's going to be very important. The pH is equal to the negative logarithm of the H plus concentration. Now, to give you some more practice with these types of questions, in your student workbook, there is a worksheet titled Calculating pH Worksheet. So please go there now. Again, it's called the Calculating pH Worksheet. You should know enough to get that done, and hopefully this video helped you.